Hello, I am Josh Bowman and I am part of Team KCJ. I designed the UV light disinfectant robot and I will be presenting my slides later.
Hello, my name is Chris Reisinger. I'm a member of Team KCJ, and I designed the brush robot.
Hello, I'm Caitlin Huang, and together the three of us create group number 19, Team KCJ. We have the duct cleaning robot swarm. Ductwork can be found in virtually all commercial buildings, as well as many residential buildings. Keeping these ducts clean is critical, as if they're dirty, it leads to a buildup of mold, dirt, and dust. This can lead to an unhealthy environment for those with allergies and sensitivities, as well as it could lead to damage of HVAC equipment. The removal of this buildup can be quite costly, and our solution provides a more affordable way. The robot in our swarm include a brush robot designed by Chris, a vacuum robot designed by myself, and a UV disinfecting robot designed by Josh. All three of these robots are designed with affordability in mind.
For our designs, our target market were HVAC technicians and companies, people that conduct ductwork cleaning, the technicians and companies that do that, commercial and residential buildings, and companies with internal maintenance departments. The impact is that the HVAC robot design and operation and robot design and operation were trying to exceed what was available on the market today. So our design requirements that it should fit inside a residential and commercial duct system, and the design should weigh a maximum of 4 pounds. It needed to have removable tools such as the brush, the vacuum, and then the UV light array that is on mine. And the design shall be able to go forward, backward, and turn left to right to navigate through the duct. We came up with dimensions of 10 inches wide, 10 inches tall, and 13 inches long to be able to fit easily inside of a residential or commercial duct system. And the design shall have a vacuum component that will pick up debris, and that was specifically for Caitlin's robot, the vacuum robot. And the design shall have a camera capable of light or dark mode and recording.
This is the brush robot, the first robot in the sequence. It will move through the ductwork and dislodge debris using the spinning brush attachment. You can see in this slide the Arduino controller, the tractioned rubber tires, and the spinning brush attachment. This is another view of the brush robot model. From here you can see the front bumper with the rubber scraper, which is used to protect the robot and push any large debris out of the way. You can see the ultrasonic distance sensor used to detect obstructions and is part of the self-navigation system. And you can see the camera module, which is used for video recording and for remote control of the robot. This is another view of the brush robot model. From here you can see an ultrasonic distance sensor. There is also an identical one on the other side. These are used to detect obstructions from the side and are part of the self-navigation system. You can see the power button, the charging port for the rechargeable batteries, and the battery status LEDs. The batteries are housed on the bottom portion of the robot along with the motors for the wheels. Each of the wheels are independently controlled to allow for maximum control. The robot itself is 10 inches long by 6 inches wide by 10 inches tall. This is the complete electrical circuit for the brush robot. You can see each component that is utilized in this design. I will be discussing these components in further detail on the following slides. This portion of the electrical circuit contains the 3 ultrasonic sensors, one on the front, one on the left, and one on the right. It also contains the 4 motors used to control the wheels, as well as the motor for the spinning brush attachment. This portion of the electrical circuit contains the batteries used to create the 12-volt rechargeable system, the motor drivers used to control the wheel motors, and the relay used to control the brush motor. This portion of the electrical circuit contains the Arduino controller. Here you can see the digital inputs and outputs as well as the analog inputs from the ultrasonic sensors. This is the logic for the code design of the brush robot. When the power is turned on, the spinning brush attachment will activate. If there are no obstructions detected in the front, right, or left of the robot will move forward. If there is an obstruction detected on the right, then the robot will continue to turn left until that obstruction is clear. If there is an obstruction detected on the left, the robot will continue to turn right until that obstruction is cleared. And if there is an obstruction detected in front of the robot, it will stop. In this portion of the code, we are defining the variables. We are defining the function that allows the ultrasonic distance sensors to read and transmit information, and we are defining the pins on the Arduino controller. In this portion of the code, we are activating the motor for the spinning brush attachment. We are reading each of the ultrasonic distance sensors, and we have the logic for moving the robot forward and for stopping the robot. In this portion of the code, we have the logic for turning the robot to the right if it senses an obstruction, and for turning the robot to the left if it senses an obstruction. As we begin the simulation, you can see that the robot is stopped and the brush motor is spinning. As we move that distance out, we can see that the wheels start turning and the robot is moving forward. As we bring the right sensor in, you can see that the robot begins turning to the left when that obstruction reading gets too close. As we move it back out, the robot returns to moving forward. The same is true on the left side. As that distance comes in and that sensor picks up an obstruction, the robot begins turning right until it sees that that obstruction is clear and returns to moving forward.
This is the vacuuming robot. It is the second in our swarm to go. It will go and suck up all the dust and debris that was dislodged by the brush robot. This is the general design of it. There's a camera and ultrasonic sensor to make sure that it's not going to hit any walls or any drop-offs. The red part over here is the canister where all that dirt and debris will be sucked up into, and there's an opening to just dump it out when it's all done. This vacuuming section is created by a fan that's powered by a DC motor. As well, the drive is powered by DC motors as well. Here's a closer look at the circuit for the vacuum robot. Behind me, which you can't see, is the battery. And then you can also see the fan motor, the right driver, and the left driver as well. This is the flow chart for the vacuuming robot. We want to start. We're going to turn on the switch that will turn on our fan and our drivers. We're going to move forward. If there's an obstacle, we want to go ahead and turn left about 90 degrees to then see, is there another obstacle? If so, we're going to turn 180, view the other direction, and then we're going to see if there's another obstacle. If there is, we're going to turn 270 degrees. That's going to have us go back in the way that we came. So we're going to move forward and start the process all over again, looking for other means to travel throughout the ducts. Here's the code for the vacuuming robot. You can see that the main things is we need to go forward and we want to turn left. To go forward, we just put the both drivers in high. When we want to turn left, we're going to actually have where the left goes in reverse and then the right stays forward to create that turning motion. Here is the circuit running. We can see the fan is running in reverse up here. The right driver is moving forward, and as well we have the left driver moving forward. But if we were to get too close, say to a wall, we're going to see that driver go in reverse, which will then power our steering. And then we're back to going forward.
Hello again. So this is my robot, and again, I am Josh Bowman. So this design is the last in the sequence, and it is going to be the UV light disinfectant robot that will travel along in the shaft and disinfect from any pathogens or diseases that might be inside. So in the mechanical design, what we have here is that um, has a camera and an ultrasonic sensor placed on the front, and then a disinfecting UV light array. It's roughly 6 inches wide, about 5 inches tall from the floor to the tires, and then uh, on the bottom right side, what we have is a closer in view of the light arrays with a switch, so that I would turn on that switch before operations commence, and then the resistor on there to make sure that we do not blow out those UV lights. Okay, so in the circuit, what I have is 4 motors connected and controlled by an Arduino, and then also I have that ultrasonic sensor. So as it detects obstacles in the front, it will redirect its path based off of what it's seeing in the duct shaft based off of distance. To the bottom left, this is just a simulated array because there weren't any blue LEDs to simulate in Tinkercad that I could find. I used red, but in my actual robot, I used UV lights. So there are 3 modes of operation. So the main mode of operation is going to be utilizing the LE Robot app so that you can have real-time control, and you can also see with the Android app what is available, or I'm sorry, what is visible within the shaft. The robot can also self-navigate using an ultrasonic sensor, and that it will be using the code to the right. I will hide my camera so that you can see the full code. And what we have here is that it will clear out the trig pin or the ultrasonic sensor. It will then start to move forward. And then if it encounters an obstacle that is um, in the way, it will either turn left or right. So in this case, starting out, it'll turn left. If there's another obstacle, it will turn right, and then it'll turn right again until it no longer encounters an obstacle. This should help with it not just turning around and coming back out. So as far as the flow chart, this is just a flow chart depicting what my code will do. So it will start, it will turn on the UV light manually, and then it will begin to move forward. If there's an obstacle, it will turn left. If there's another obstacle, it will turn right. And then if there's still an obstacle, it will again turn right. And that should clear it out to where when it goes back to, is there an obstacle, it will say no, and we'll move forward. And then at the end of the duct cleaning operation, it will terminate. For collective behavior, what we have is the 3 robots in sequence. So beginning with the brush robot, followed by the vacuum robot, and then lastly will be the UV disinfectant robot. It will then travel along the shaft, and depicted here, they will come across an obstacle and then turn left to mitigate that obstacle.
From a financial standpoint, each robot was built using the same general robotic and component kits, as well as several breadboards. Unique to the individual robots were the spinning brush attachment, the vacuum pump, and the UV sanitizing lights. After pricing everything out, we're looking at just under $500 total to build all 3 of these robots. As previously mentioned, duct cleaning services are not a new concept. There are several robots on the market, but as you can see, when compared to our design, they are much more expensive. In summary, I believe our team has designed a system of ductwork cleaning robots that is at a fraction of the fuck. Designed a system of ductwork cleaning robots. Effective. In summary, I believe our team has designed an effective system of ductwork cleaning robots that comes in at a fraction of the cost of options that are currently available on the market.